Hi, good evening. Thanks for showing up for this session. We'll be talking about GraphQL again. This time, I'll try to be your GraphQL field guide. So first things first, just in case you don't know what GraphQL is, I'll start with a very quick crash course. So what's GraphQL? It's a query language for your API. It looks a little bit like this. So clients send queries that look like JSON without any values, more or less, with the obvious exceptions that fields can also have parameters. So you can see here, project takes a parameter, for example, and so on. So what this query says is that the client would like a project with code legendary, it would like a description, it would like a task belonging to that project, filtered by the status ready, so only ready tasks. And then from the task, we would like description and status again. So it can ask for deeply nested structures. That's a key point to take here. It gets a result that looks pretty much the same in structure, but with values populated. So if the query is JSON with no values, the result is, well, regular JSON. It also has a type system, which you may have already gathered from the previous slide. So for a query like this, the types would look maybe like this. So you would have the root query, so exposing all your top-level queries. You have the project query that we're calling here. It accepts a code of type string, and it returns a project. So again, a typed thing. Project is then defined as an object type that has code, description, and tasks properties, where tasks can be filtered by status, and it returns a list of tasks. So the square brackets are a list. And then further on, task has its own fields, status, description, related tasks. So the interesting thing to note is that you can have circular relationships here, like task can have other related tasks connected to it and so on. Status is a enumeration in this case. I didn't list it, but yeah, it's a simple enum. So why you would want something like this? You already have multiple ways to talk to your backend, right? So why another one? Well, GraphQL promises that the client will never have to under or overfetch, meaning that client is in charge of what they get. So they choose what data they get back. Unlike with REST, for example, where the client just hits an API and the server returns whatever it wants, here the client is in the driver's seat. If they ask for one project with only the description inside and then in the tasks, and tasks already filtered, and then inside they want just this, then that's what they get. They won't get extra stuff like related tasks or whatever else. The results are always predictable, as we saw, so the result will always have identical structure to what the request had. So the client always knows what a result will look like. It will never be surprising. Even if the new fields are added in the backend or something gets changed or whatever, the result will still remain completely predictable for the client. They'll never receive new stuff or anything surprising. And perhaps the most interesting feature is it also has introspection, meaning that the client doesn't need any additional documentation or anything at all to consume your API. They just need to know your one single endpoint that you expose, and they can introspect everything from there. They can discover what operations you offer, what inputs are necessary, what outputs to expect, what fields are nullable. Everything is already built in, basically. So that's another cool feature. So let's see a canonical or maybe not canonical example how you would model this in REST. So the application that I'm using in this example is something like a Jira or a Trello or something. So it has a project has tasks, and tasks can be ready or in progress or whatnot. So let's say you want to render a project page. So you have a project with a name there, and then it has some tasks on it, and tasks are in different stages and so on. So canonically, at least, what you would start off with in REST, you would have something like this. You would maybe first fetch a project. So by ID, projects 1, then you would that would give you a list of tasks belonging to that project, among other things. Then you would go and fetch data for each of the tasks. So that would be at least 4 round trips to the server to render this. Yes, of course, you can do things about it. You can optimize by doing, I don't know, something like this. You can say, I would like the projects, and then with tasks expanded. But then different clients might mean different things when they say expanded. They want tasks, but what what inside of tasks. So you can do something like this where you actually list out what you want expanded, but you can start developing a whole little language here for just doing that. And of course it's non-standard, so it's not like any client will help you with this. The client just has to know that this is the way you do it by some other document or something. Of course, you can just create a custom endpoint with all the stuff I need. And then in 2 months, you will have version 2 of all the stuff I need, of course. And and then you will have a mobile client that has a different idea of all the stuff they need. So they need everything, but not the description, because they don't render that. And so on. So there are different ways, but they will all lead you to one hell or another. And that's only stuff that the client needs to be aware of. So you as a maintainer of the server, you also need to do a bunch of stuff. So you need to create all these new endpoints or update their logic for expanding fields or whatnot. Then you need to update your models that back all this data to have new fields or whatever it is that you changed. You need some kind of document to tell the client what their options are. So it could be Swagger or RAML or whatever you're using, but an external thing, yet another thing that you need to maintain and make sure it's in order and understandable, and the client needs to be aware of this. And then there's many standards, of course, for REST that try to streamline at least some of the problems, like JSON API and HAL and Siren, and of course there's a million of them, and of course the client has no way to know which one you chose without, again, looking at some documentation or something, and just oh my god, like no. Instead, you can just do this. Just let the client choose what they want. They can tell you they want a project and names and tasks, and that's it. One go, they receive everything they asked for in one go, and that's it. No round trips extra or anything. So what happens if you approach applications like this is you get a pretty radically different architecture than what you would have with REST. So in REST, you typically have a client talking to an endpoint then talking to one or more services, some third-party stuff or storages or God knows what, and then fetching all the data that it needs and merging it back and then sending it back to the client. With GraphQL, it works quite different. So for each individual field that a client asks for, like in the previous example, they ask for project and then name and then tasks, and then inside code description. So for every single of these, for project, for tasks, for code, for each one of these, there's a specific function, resolver function, that is in charge of fetching the value for that field and that field alone, nothing else, just one value for one field, highly contextual. So these little boxes here, they will basically be your resolver functions, whereas in REST, those would be your entire endpoint. That's why they're big, and here they're small. So typically a resolver function never needs to talk to multiple things. It usually just gets one value from one place. Of course, resolvers are very often just trivial. They just call a getter on the parent object. So for example, to get a code of the task, you just say task.getCode. So you don't need to write those. But if they have more interesting data in them, more interesting logic, then you would have to write them out. And that's your main job as a developer with GraphQL, to write those functions. And then it's the job of the GraphQL engine to merge that back into whatever shape the client asks for. So the engine will parse the query for you, figure out what resolvers to call them, merge the results, send back to the client. So you get this out of the box. Now, truth bomb. It's a query language for your API, not your data. It means GraphQL should be speaking your domain language. It should be speaking actual business cases that you have, whatever is it that UI wants, for example, or something like that. It should not be just dumb CRUD operations on top of your database tables. So if you're just making a replica of your one-to-one replica in your GraphQL types to match your database tables and columns, then you're basically not getting any value out of GraphQL. And potentially even worse, there's much easier ways to do that. So it would be just a high ceremony way to get the same thing again. So don't do that. If you're modeling a shopping cart, for example, then you should have operations like add item to shopping cart that accepts a whole item object and something like that. So something that directly speaks the model language that you're working with, expresses directly a business case that you're trying to solve. So let's see how you actually do any of this. So There are two general ways you can start developing your GraphQL application. First and most obvious one being the schema-based one. So you start off with a schema. So you write a schema. So exactly like this, like it's just a text file where you describe everything. So you say schema has a root query, and then query exposes projects that are filterable by start date here, for example, and then project has tasks that are filterable by type or something, and so on and so forth. So you write this as a text file. Then you literally start with that. So you parse the text file, and then you wire the logic in. So you attach, so look at the yellow stuff, basically how it connects. So you attach logic for each of the fields that needs custom logic. So if it's trivial and you just call a getter, you don't need to write it. But in all other cases, you do it like this. So you attach logic, for example, to the way to fetch project fields is by calling some project service or something that you have in your application. To fetch tasks, you call something else, and so on. So write the schema first, wire logic in, merge them together into something called executable schema. That's what you're after. That's what you use to fire the queries against. So once you have that, you're done. So that would be high level what it looks like. There's a different approach that library that I work on takes. It's called Codefirst approach. So the library is called GraphQL SPQR. If you're interested in it, Google. I held a talk about it this Tuesday, so it will be online as well. So in that approach, you start with the code you already have, or well, that you're writing. So you have your project service. It exposes the methods for searching for projects based on start date, and it will talk to some database or something behind the scenes. So you need a way to somehow expose this, to say this method is what backs the GraphQL API. So the most obvious way is to just slap an annotation on it and say, okay, I'd like this method exposed. There are alternative ways, of course, to do it. From there on, you create a schema generator, you register a service that you would like exposed, and it generates a schema. And then from there on is the same thing as you saw before. So you have a schema, so you can create a GraphQL object out of it and then start firing queries against it. If it gets more interesting, let's say our projects are crowdsourced, for example, crowdfunded, sorry. So you would like to also be able to get a current funding for the project. So you would like basically to add a field like this. So okay, you can get a project and get its description and whatnot, but you would like also to be able to see how the funding is going right now. And you have your code behind this, so you have something representing a project, right? So you would like to add a field. So yes, you could technically just add another field that goes and talks to Kickstarter and fetches the value, but that would be all sorts of terrible, because now suddenly your simple data object is making web calls and has business logic in it. So of course that's terrible, so that's not what you want. Instead, you have your project service, contains the logic there. You would add a query like this. It's a query like any other, annotated as usual, except that it has this context thing, which means it will be nested inside of project. This is how you assemble a graph without messing up your data model. So now the logic for fetching this value is in the service where it should be, where the rest of the logic is, and your project is untouched. So that's just quickly about SPQR, but that's not the main topic. So I'll do a super short demo of the stuff that I told you about. Oops. Just to mirror my screen. Cool. Okay, so that's my IntelliJ. So what I have here is a very simple project that looks like the example that you saw. So it has just the usual stuff. There's pretty much nothing GraphQL specific in it. It just has some pojos and a couple of repositories for fetching projects and tasks and whatnot. And then finally the service classes being the interesting ones. So I have a project service. It's a normal Spring service in this case because it's a Spring application, but that's not strictly relevant. And it exposes some queries, like we said. So you can fetch a project by code, you can create a project. So notice the notation here says mutation. So mutation in GraphQL is basically a way to, it functions exactly like a query, with the difference that it makes changes and not only fetching stuff. So logically it's an equivalent of a post or a put request in REST. So, okay, so we have a mutation for creating a project. We might have something more interesting as well. We have our nested field here. So for current funding, here it just does some silly stuff like randomly generates stuff, but that's not entirely relevant. And then you have this lovely application called GraphQL Playground. It's basically a generic client for GraphQL. So you can use this during development or at any point to just play with your API. That example that you saw was using a Speaker Spring Starter, which is a very quick way to bootstrap your application. All I had to do was add those annotations, that's it, and I can start playing with it. So you can just run queries. So you can see, for example, I have a mutation here for creating a project. I give it a name, legendary. It's a dairy shop or something. I assign an owner to the project, I add some tags or whatever, and then I ask for code and for current funding and for tasks back and so on. So I can create this project, I get a response like expected. Tasks are of course empty, we didn't add any tasks. I'll create another project called potato salad. I'll create a task for the legendary project. So you can see I'll call, again, just a mutation, create task, project code, description, and so on. It's a type purchase because buying a cow is a purchase. So I'll create a task. Okay, now I have that. You can ask for all your projects back. You can get stuff. So basically just what you would expect from something simple like that. There's an interesting thing to note as well. It's possible to, there is something called a subscription, so check out that. Subscription is basically a way for the client to subscribe for some type of event and then receive push notifications from the server about it. So in my case, I can follow a task, for example. So I want to see whenever the status of a certain task changes, and maybe, you know, re-render the UI or something whenever a status updates. I want to automatically do that. So you can also do that, and it will start listening. Then in a different thread, I can change, for example, the status to work in progress. Now it's work in progress. Oh yeah, notice how I have autocomplete, because of course all the types are known ahead of time. Everything is typed already, so it can help you with autocomplete and stuff like that. So I can say, okay, now I'm done with this task, for example. And then in the first tab, you see immediately how we received each of these notifications. You can stop listening as well. So the way this is done in backend is using this annotation, so subscription. Of course, that's the easy part. The harder part is how you actually get the values. So you need to return a publisher. This is the Java 9 style reactive stream, or well, not necessarily Java 9. RX and Spring Reactor also implement the same standard. So here, because I'm using Spring, I'm using the reactor. So Flux, create, and then I just store it for later, the subscriber object. Basically, I just keep it in a map. And then every time a task is updated through this mutation, update task, what I do is I find all the subscribers, and then for each subscriber, I fire next with a new task, so it immediately gets pushed. But that's just something I wanted to show you quickly, not really the main thing. So let me go back. Okay, so you can play with that more. Just Google GraphQL Speaker and you'll find the details. Time for another truth bomb. Some problems get way harder with GraphQL. For example, now the client is in driver's seat. As we said, they can ask for whatever they want. So what if they are malicious? They can do strange things. So queries can be arbitrarily complex, meaning that a malicious client could just ask for the entire universe, or ask for a result that's going to be like 10 gigabytes or something, and then, you know, destroy the server. So there's a couple of things you can do about malicious queries. One way would be to analyze the abstract syntax tree complexity. So basically you take the request, you take the query that the client sent, and then analyze how complex it is, where the notion of complexity is up to you to define what it means. One way to do this, using Speaker as an example here, you can assign a complexity expression to each field. So here I'm saying that yeah, I can get projects by start date and then its page, so I can say the page size and page number, so I can calculate how many projects there will be in total. So I can say page size times child score. So whatever is the score, the complexity of one project times page size, that's the complexity of fetching this. So here it's a simple math expression, but it could be anything you plug in here. So for example, you could be keeping historical values, for example, how long it takes to do something. And then the moment a service becomes less responsive or slower, you can increase the complexity for it. Or maybe complexity is not the best word, maybe expensive or something like that. So you increase the cost of this specific field. And then it will for you calculate for the entire query how much it costs, and then if it's above some threshold, it will just reject it straight out. So that's one way to approach this stuff. You can monitor performance, for example, and then decide whether some query is too expensive or not, and make use of those values as well, or just keep it simple like this. There's an even simpler way that might be enough, actually, to just limit the depth of the query. This is what GitHub is doing, or at least was doing. They were limiting the depth to 10. Oh yeah, in case you didn't know, GitHub's API is all GraphQL. So they're limiting the depth. In GraphQL Java, it's very simple because there's a built-in instrumentation for it. Instrumentation is something like a servlet filter kind of thing. It can intercept requests. So here we are adding a max query depth instrumentation 10. That would, if the query is very deeply nested beyond like 10 levels or something, we just reject it and that's it. Then you can, of course, if it's possible, you can also limit the execution time. So if you have, for example, a thread per request, you can monitor how much it's running and then somehow interrupt the thread or terminate it or do something like that and then protect yourself in that way. Or abort a database transaction if you know the entire thing is happening in a database or something like that. This is kind of an extreme approach, but if you control all the clients, if all the clients are written by you, then you can simply not even send the queries, just sort of some hash code or something, or whitelist all possible queries or something like that. It's not as often applicable, but if you control all the clients, it's something you can do. And then when it comes to the size of the result, currently there's not really a good solution to that, so you should, well, I mean, in GraphQL Java land, but what you could do is stream the results. So instead of fetching the entire thing and then sending it to the client, you could stream it as you resolve field by field and then keep streaming into the client. There's some work going on with this, so in very near future there should be support coming for that too. So next interesting thing that gets tricky is how to optimize fetching. So for a query like we have projects and then we want stuff from it. Let's say projects live in standard relational database. So we would like to do a select to fetch project object, but you don't know what fields, at least right away. So you could do something like project select star from project and get everything, but then you would like to optimize that, right? So you need to know sub-selections of the field. So at the time you're resolving project, you need to know what will the sub-selection be. So the way to do that is through this data fetching environment. That's something that's accessible to each resolver function. GraphQL Java gives it to you. So from there you can get the selection set and then find out the fields that you need. In this case, the fields would be code description and tasks. You can go deeper as well. So you can say, aha, okay, so if I have tasks, then that's a different table. So I need to preemptively join or do something like that. So you can go as deep as you need to figure out how to optimize it. You can use glob expressions to reach into it and see what structure you need to produce, and then preemptively join and do whatever you need to optimize the fetching. So that's one thing you can do. In GraphQL Speaker, it's pretty much the same story. You just inject an argument using this GraphQL environment annotation. that will give you access to a resolution environment which has the same things that you see above. So same style. N+1 is especially tricky in GraphQL. So remember how we had the current funding thing that talks to Kickstarter. So let's say this fetches all projects. It doesn't filter, it doesn't page, it just gets all the projects. So let's say we have 10 projects. And then for each we need the current funding, which means that 10 times we need to talk to Kickstarter to get the current funding. That's terrible. So that's, well, each of these will be called n times, but an interesting one is the current funding because it talks to web. So the prime solution to this is data loader library. It exists in many languages, but we're talking Java here, so you are looking for data loader Java. How data loader works is you supply a function called batch loader. Batch loader function is able to do exactly that, to load a bunch of values using a bunch of keys. So in our case, we would receive a list of projects and we would return a list of longs. So where long is the amount of the funding. It all works async, so with completable futures all over the place. So here you need to implement basically this logic. So how to get fundings for multiple projects. So imagine the Kickstarter client has get for many or something like that, where you give multiple project IDs and then fetch funding for all of them in one go. Or it's much simpler if you're talking about database, where you would just fetch and say, for example, select from projects where ID in and then list. Select from funding where project ID in and then just list the IDs, and that would be batch loading it, for example. That's a very simple style how to do that. It can get tricky if you need to fetch deeply nested things in a batch, so it can get tricky, but it's always possible. So that's the batch call. And then from the batch loader, so you notice the batch loader function is just stateless function, nothing special. Data loader is usually a request scope, so that's an object that also does implicit caching. So if you keep asking for the same project 5 times, for example, it won't ask for it 5 times. It will just implicitly cache. So that's why you normally want it request scoped. You don't want other people's data, but it's also possible to scope it differently if you actually want it. And then inside of your resolver functions, you would do something like this. So instead of directly fetching a value, you would now use the loader to get the value. So you would say funding loader dot load for this project. Okay, this is silly because the loader now accepts ID, and here I say it accepts project. That's a bug. It should say load for this project. And as a result, you would get a completable future, sort of a promise. In a different data loader, different resolver function, you would call the same data loader but with different keys. So you would say, get me the funding for project 1, here's a promise of the result. Get me for project 2, here's a promise of the result. So you keep getting these completable futures. Thankfully, GraphQL Java already knows how to deal with it. So if your resolver function returns a completable future and not a straight value, it's fine, nothing changes, all works exactly the same. So you can keep doing this basically. You keep getting promises of the result, and then eventually the batch loading is dispatched by a dedicated instrumentation that's already registered. So it already exists in GraphQL Java. I'm just drawing your attention to it. So this will batch load everything, and then all these completable futures get resolved, and then that's it. You get your thing. Another interesting gotcha potential is authorization. So the thing with authorization is that there are multiple ways to approach it, basically. So first things first, who can fetch specific fields? So now you are exposing this whole API to the client, and they get to choose what they fetch, but not everybody can fetch the same things, right? So you could start with something like this, for example. You could, in your schema, you could say that the current funding is only accessible to managers. So this, what you see, is called the yellow thing, the auth, is called a directive. It's the exact same thing as an annotation in Java, just in GraphQL terminology. So it's a custom one. It doesn't exist by default in GraphQL or anything like that. It's just a directive that you can add by yourself. So here I call it auth, and it has a parameter called role, and it says what role you need to be able to access this. So funding available to managers only. And then in Speaker, you could, for example, use a custom annotation for this, or not custom annotation, but Spring Security or something. You could just do it that way. And then in your runtime, you can check for the presence of the directive and then make a decision. You could even do this from instrumentation. You can say, at the time field resolution starts, you check if there's a directive on it. If that's an auth directive, you check, does the user have this needed role? If not, we return null, for example, or something like that, and tell them that they can't fetch it, or throw an error, or whatever is appropriate. So that's about who can fetch stuff. But there's another problem. Who can see specific fields? So that's a different story, because you might not even want all the clients to be aware of the existence of fields. So not only that they can't fetch them, they shouldn't even know they're there. Because just knowing that there's a protected field is already half the battle for the hacker, right? So there's a concept of GraphQL field visibility. This is something that you can register with your GraphQL object that you use to fire queries. So you can implement a custom field visibility. So it gives you a hook into this logic of choosing whether a field is there or not dynamically. So you implement this method called getFieldDefinition, and then from there you can check whether the field has a directive or an annotation or whatever you're using. Check that way, and then make a decision. Say yes, the field is there. You can even show a different field altogether dynamically, technically, but don't do that. That would get very strange. Otherwise, you say return null. That means this field doesn't exist for this client. So even if they do introspection and check what's available and whatnot, they'll just never know this field is there. So it's step even in further in security. This is very hard to do with REST, because client has this innate expectations of what comes back. So they have to know at least what fields are there. So this is even a step further. Caching is extra interesting, I would say. Because what you get is, caching is no longer simple. In REST, caching is very simple. You have a unique URL, you hit it, and you use it as a cache key, and that's it. It could be per user or global, but that's pretty much where it ends. So here it's much trickier, of course, but it's also granular, which is a good thing in a way. So you get some ups and downs with it. So you could do something like this. Again, this doesn't exist out of the box. You would have to develop something yourself. Well, there's a caveat I'll mention. So you could have specific cache control per field. You can say, okay, so funding is cacheable for 500 milliseconds or something. And if I'm asking for myself, for example, get my own profile, I say query me, user, then cache control is saying private, which means that it's cacheable, but for me only, it's not shareable with other users, for example. Then what you can do from there is develop a custom the filter thing, my mind just stuck, I cannot remember what it's called, the instrumentation, yes. That will check all the cache controls for each field and then find the shortest expiration time. So let's say this is cacheable for 500, something else is cacheable for 200. That means the entire result expires in 200, and then you can send that 200 millis as a cache control HTTP header, send that to the client. Then basically the client, just the browser will know that it needs to refetch in 200 millis. So you can do things like that. So make it more granular, basically. So you lose the simplicity of the caching, but you get fine tuning of it. So that's one way. There is also an interesting product available that you should be aware of. It's called Apollo Engine. What Apollo Engine does, it's acting as a proxy between the client and your server, and gives it a bunch of extra features. So actually, this cache control annotation is directive is coming from Apollo. it already knows how to do what I explained. So it already knows to inspect the result, find the meta info about caching, decide what's the appropriate time, so the shortest expiration, and then send that to the client. It also has other cool features, like for authentication and things like that. So you should be aware that it exists. It's compatible with, well, any GraphQL backend, so Java or not. There is another interesting thing that you can do. It's called schema stitching. Somehow it's not particularly popular in Java circles yet, but it's what you do when your GraphQL endpoint needs to talk to other GraphQL things to fetch data. So what you can choose to do is just expose that entire thing as one big schema. So you stitch multiple schemas that come from different places into one big thing that automatically knows how to delegate calls to the specific backend. So we have a couple of libraries in Java ecosystem that will help you with this. One being GraphQL Braid. It's developed by Atlassian. It does, well, exactly that. It braids multiple schemas into one big thing. There is a project called Nadal. It's developed by GraphQL Java team, but it's like super early alpha, experimental. God knows what happens to it. So maybe it's more, at this moment at least, it's more inspiration than something you should really do. But what it does, what it gives you is a way to, in your schema definition, basically even go further. You can say that to get this value, go to this REST endpoint and fetch me results, for example. So you don't even need to write the REST fetching part, the web calls and things like that. So it goes step beyond. There is a similar project also developed in Sangria by the GraphQL Sangria Scala guys. So check that one out. It also has very cool ways to develop these like mega schemas that just merge different things. And if you go further on with this type of thinking, you can come up with sort of a API gateway where you would have multiple, microservices or whatever the popular thing these days is, and then have a gateway that just knows how to delegate to those automatically. It merges the schemas together, distributes the calls as necessary, and so on. So it can be quite involving. And finally, of course, you can do a similar thing by yourself. Just write a mega schema, and then you could use a dedicated GraphQL client to call other GraphQL endpoints. For Java, there's not that many options at the moment, but there is Apollo Android, which is called Android, but it's a normal Java client that you can use to shoot requests to other GraphQL endpoints. Of course, you can just use any HTTP client. In the end, there's nothing special about this. You still just send a HTTP request with a query and get a response back, right? Okay, so there's a couple of more topics that are that would be perhaps interesting to explore in the future, but this is it for now. I'll fire up my my demo again to show you data loader in action and maybe some other interesting bits there. Okay, so here's the data loader bit, which I kind of hand-waved in my first iteration of the example. So I have my current funding extra field that I added into the project type. And the way I then access everything, I inject this resolution environment with this annotation. From the resolution environment, you can access data fetching environment, which is the low-level thing that GraphQL Java gives you. From there, you can get a data loader. I'll show you how to write those and how to add them. So you have a data loader. In my case, I get the one called funding. And then you say funding loader, load for this project. And it will give you back a completable future of long in my case. So the way you wire this in is like this. So you create your batch loader function. In my case, it's very, very simple thing. It doesn't do anything smart. It just generates some random numbers and say it got them from Kickstarter. So this being that. So it just generates a bunch of random numbers, that's all, and gives me a list of random longs. You then create a data loader from the batch loader. So again, batch loader is stateless. It's just a simple thing that's shared between everyone. So whereas data loader is not, it's caching, it has state in it, so you have to be careful about the scoping of that. So you create a data loader, you create a registry, register your loader with a name. That's the name that I used here when I needed the data loader. I register it with this name, that, and then the magic of this Spring Starter would wire it correctly so that you have access to it in runtime. So that's one way to do things. Yeah, I showed you the subscriptions. Maybe another interesting thing would be to see paging as well. So here's a example with paging. So I mean, there's nothing magical about paging. You can just give, limit and offset and return a list, and that's it. You have paging. But there is this optional specification for doing a bit more complex paging. It's intended for cursor-based paging, but it can be retrofitted to limit offset simple style paging. So here I'm doing that. I just accept a limit and an offset. I give the default value to offset of 0, so you don't have to provide it. It means just start from start. If you would like to rename a field, you can just do it this way. And then, yeah, there's a helper called Page Factory that allows you to turn a list into this complicated page object. So let's see that in action when you start firing queries that way. So here's a query that is using paging. So I can say, okay, I'd like projects page, maximum 2. I would like page info, so to know what's, if there is a next page or previous and so on. And then from each project, I would like to get this name and stuff. So projects page, and then you get something like this. So it's a bit more, yeah, gives you a bit more insight than just simple limit offset. It's interesting to note also how what I said, the client has full knowledge of everything just from having your endpoint. So here you can see, you can explore the API. You get to see all the top level queries. So I have projects page, I have a task and projects and so on. I have mutations for updating, creating stuff. I have subscriptions. You can click any one of those, see all the types that are involved. You see exactly all the data that you need to provide. You can see here, for example, the exclamation mark means it's not nullable, so it's a mandatory field. So even that you can know automatically, and that's it. So that's all the info you needed to supply to the client. You can attach descriptions and whatever you would like the client to have. Okay, let me go back. All right, and my mouse is gone. Okay, I have no idea where my mouse is. Something happened and I cannot, it got stuck. You still see that? There. Let's try again. Okay, back to normal. All right, so that would be pretty much it. So you can find more info about the whole speaker thing, or find me, or follow me on Twitter or whatnot in these locations. And you have 5 minutes for questions. Fire away. I like how you appreciate that. Yeah, please.
Can you auto-generate the client code?
Yes, you can, and that's a very interesting proposition. So I'll repeat the question. Can you auto-generate client code? So you mean in the style of WSDL to Java, where you get like a client that knows all the types on the server and all the functions and so on? Yeah. So yeah, you can do exactly that. There is currently for Java, there is only one library that does that. It's open sourced by Shopify. It's called GraphQL Java Generator or something like that. You can register it as a Maven plugin and then it will generate the client for you, but it has a pretty big downside of requiring Ruby to run. I'm actually thinking of starting another thing and writing one myself, but yeah, it's totally doable and it's something that will surely happen one way or another. Anyone else? Nope, you're all happy? Okay, then you're free to go. Oh, sorry, yes, please. Yes, you can check it here. So you can go just to lingen.io, it will redirect you to our GitHub. Change your mind? Okay. No more? Okay, then that's it. Thank you for coming.